How did I get both the box plots on at one time? Well, I went second stat plot, and I went into stat plot number 1, and I did my list 1. And then let's see, you can actually go up to plot 2, or you can just hit second stat plot again. Arrow down to plot number 2. Turn that one on, and then I put in list 2. Made sure I didn't have anything on my function screen, my y equals screen. And then I just did a zoom 9 and plot them both. Nice to be able to get them up both on the same scale. So my box plots, and I would copy them down, but I have shown them to you, and I actually have them on film, so I'm not going to copy them down. They show no outliers. Okay to use T. And then for independence, sorry, we just need to check that the observations were independent. When we took people's blood pressure, and that these two groups are independent. They are not a paired sample. And so you have to go back to the design of the experiment and to decide all of that. Okay. Now, if I have named my test very well, I am just going to run my test. So I'm going to hit the stat key. I'm going to go over to tests. I got to figure out which one. I got 2 sample. Where are we going? 2 sample t-test. Looks like it's on the first page. So number 4. Go on to number 4. If I have data in my lists, I put down list 1, list 2. If I don't have data in my lists, I go to stats, and I have to enter the mean and the standard deviation and the sample size for both of those samples. But I got data in my list, so that's where I'm going. I'm doing a greater than test. And let me go down here and tell you that we always say no to pooled. We do. And the reason is that pooling means that we put both of our samples together and average out their standard deviations, and we're able to use a high degree of freedom. It'd be both sample sizes summed minus 2. I can use that high of a degree of freedom. But I'm only allowed to pool if I think the population variances, the population standard deviations, are equal. And we don't know how to test to see if population standard deviations are equal. So since we don't know how to run that test, you're going to always answer no to pool.
Wait, is there actually a way to test that?
Yeah, it's a F-test. It's, you know, yeah, there's just another distribution. You know, it's just, yeah. It's fairly simple to do, but we don't cover it. One more test. All right, now I'll hit calculate, and now I get to read some numbers off my calculator. I need to put every number down that comes out on this calculator. So T is 1.60. That's good. Let me read the rest of my calculator off to me. It says P is 0.06. It says degrees of freedom is 15.59. You can use that. We had a sample mean of our first sample. That was list 1. That was the calciums. of 5 and a sample standard deviation. Oh, they put it in a different order. The sample mean for the no calcium, they said, is negative 0.27. Sample standard deviation for the calcium group is 8.7. And for the no calcium group is 5.9. And sample size is 10 and 11. So if I just write down everything that spits off my calculator, I don't have to show that formula if I have properly named my test. Okay? Otherwise, write down that whole formula that I gave you yesterday. Okay? Next. Step 4. Obviously doesn't come from the calculator. So my p-value was 0.06. What alpha would you like to use? Okay. So we are greater than 0.05, which is our alpha. We fail to reject. Our null hypothesis. We do not have evidence that calcium supplements supplements improve blood pressure. As simple as that. Or you could say have a higher average decrease in blood pressure than people who don't use calcium supplements. You can get pretty specific on this one. You don't have to get so darn specific. Now, the degrees of freedom that's spit out by the calculator is this calculation that's based on standard deviations and sample sizes. And this degrees of freedom, you don't actually have to know what this formula is. It's used because in reality, the two sample sampling distribution is not really a t distribution. But it's close if you use the calculated degrees of freedom. Those two degrees of freedom are always greater than the degrees of freedom that you would use by the smallest sample size minus 1. So they actually buy you something. They actually buy you a little more room to reject the null hypothesis because you're raising your degrees of freedom. But the formula for that is in the book, and it's something that you just allow software to calculate for you. You don't actually have to memorize that formula. Okay? Confidence interval. Where would you go for looking for confidence interval? I'm going back to the tests page. Do you see the confidence interval here yet? Yes or no? How far do I have to go down for the confidence interval? 0. 2 sample t interval. Okay? It puts my list 1, list 2 back in. I think if I did stats right now, it would give me those stats that it just calculated. So at this point, I can go stats or data. It asks me for my confidence level, and it asks me if I'm going to pool. And I answer no to pooling. And I get a confidence interval for the average average decrease in blood pressure of